For the question 1a, without eliminating theta, find the exact value of second derivative when theta is pi over 4. So given the value of x and y, and we need to differentiate x respect to d theta and y respect to theta. And then we substitute the value into this formula by using chain rule. And then we solve the question by cancel out square root 17. And then we get the answer negative cotangent theta. And then for the second derivative, we need to differentiate the first derivative to get the second derivative. So as we get the answer negative cotangent theta, so we substitute into this formula. And then we solve the question until we get the answer negative cosecant cube theta over square root 17. Then we need to find theta equal to pi over 4. So using the answer we get in here, so we substitute the theta with pi over 4. So we get the answer to square root 2 over 17.
Question. Okay.
Yeah.
How do we get cosecant square theta up here and then down there it become cosecant cube theta?
Okay. We factor out 1 over sine theta because it can convert it into the cosecant. You
Okay.
get it?
I understand.
Okay. For the 1b question, find the arc length of the curve. Give your answer in terms of pi. So the first step, given the formula arc length in this question, so we substitute the following formula in value we get from 1a, which is negative square root 17 square sine square theta plus square root 17 square cos square theta d theta. So we simplify the step with identity trigonometry until we integrate square root 17 theta d theta by upper limit pi over 2 and lower limit 0, and we get the answer for the arc length, which is square root 17 over 2 pi.
Okay, now we want to know how to find the polar equation for the curve. Firstly, we want to know what is polar equation. Polar equation is equation that contain r and theta as in the coordinate polar and also in the polar equation. Commonly, we use x and y in the equation, right? Also with in the coordinate. The x and y, we call it as a Cartesian equation. And for polar, we use r and theta. To get the polar equation, we use x equal to r cos theta and y equal to r sin theta. How do we get this? We get it from the graph, right triangle and Pythagorean theorem. Because we express the cos theta equal to x over r and sin theta equal to y over r. And then we rearrange it by express the x and y. So we get x equal to r cos theta and y equal to r sin theta. So it's proven lah.
Miss, excuse me, Miss. Can I ask how do we get the
Alright.
cos theta equal to x over r and sin theta equal to y over r?
Okay. Cos theta equal to x over r, we get it from this. Cos is adjacent over hypotenuse. So the adjacent is x, and for hypotenuse is r. So we get cos theta equal to adjacent over hypotenuse, which is x over r. Same goes to sin theta equal to y over r. We get it. So a sine is opposite over hypotenuse. So the opposite is y, while for the hypotenuse is r. So we get it sin theta equal to opposite over r, which is y over r.
Okay,
Get it?
got it.
Okay, thank you. Good. Let's jump to the question. First, for the polar equation, the given equation is parametric equation. So from the parametric equation, x and y, this two equation is parametric equation. So we want to change the parametric equation to Cartesian equation by using the Cartesian method. So the first step of Cartesian method is we need to eliminate the theta as follows, which is it means that we express the cos theta and sin theta from the parametric equation. And then by using the trigonometric identity, which is cos squared theta plus sin squared theta equal to 1, we just substitute the cos theta and sin theta in the trigonometric identity. And then we rearrange it until we get the Cartesian equation, like this. And then after we get the Cartesian equation, then we can convert it to polar equation by using, remember that in polar equation, we must use x equal to r cos theta and y equal to r sin theta. What we need to do, we just replace it y and x in the Cartesian equation here and here, and then we get like this. The next step is we just expand the bracket, the terms in the bracket, and then we isolate the trigo term, this one and this one, until we get the like this. And then after that, since we know that trigonometric sin squared theta plus cos squared theta, sorry, I forgot to put here theta. Since we know that sin squared theta plus cos squared theta equal to 1, so we just replace it here by 1, like this. So it turns out to be, and then we express the r squared. We move this term to the right hand side until we get the r squared theta equal to negative 2r bracket cos theta minus 4 sin theta. To get the polar equation, which is r, we need to divide all the equation by r to become the r squared become the r, which is the polar equation. So the r squared tends to be r, and then we cancel out this part, r this one and this one, and then we got r equal to negative 2 bracket cos theta minus 4 sin theta. And then last answer is we need to expand the negative 2 into the bracket here, and then we got negative 2 cos theta plus 8 sin theta. Get it?
Question 2. At time t equals to 0, a ball is thrown straight up from a height of 5 meters off the ground. After 30 seconds, its distance s in meters is given by s equals to 5 plus 4t minus t squared. By completing the squares, find the maximum height of the ball above the ground. Since we are given the equation of s, we first convert it into a quadratic equation, and then we will use the completing the squares method, which will give us the x and y values of the curve of s. We will solve until we get t squared minus 4t equals to 5, and then onto the next step, we will add another constant, which will be negative 2 square, and then we solve until we get t minus 2 in bracket squared equals to 9. Therefore, yes, is there any question?
Sorry, I want to ask, how do we get the negative 2 squared?
Okay, so in this case, we get negative 2 squares by uh, dividing the b value. So in this equation, our b value is negative 4. So if we divide it by 2, we will get negative 2. And in the completing the square method, we will square the c value. So negative 2 is squared and added to both sides of the equation. Is it okay? Understand?
Clear. Thank you.
Okay. Therefore, the maximum height achieved by the ball above the ground is 9 meters when t equals to 2. Question B. Sketch the graph of s against t. So we know that we are given the equation of s and the initial point to be 0, 5. So we need to find the terminal point, which is t equals to 5, and we get this by expanding the equation from 2a to solve t. And now that we know the initial and terminal, we need to plot the graph after getting the value of t, which is t equals to 0, 1, 2, 3, 4, 5. And for that, we need to build the table shown with the corresponding S values. And now we move on to making the graph. So our y-axis will be the distance and our x-axis will be our time. We have currently 3 points, which is the initial point, the maximum point, and the terminal point. We now only need to fill in the t equals to 1, t equals to 3, and t equals to 4. And now we can finally sketch the graph, which is shown.
Okay. In question 2.c, we have to find the different type taken of the ball, which the height is 5.5 meter above the ground. Okay, we are asked to give you the third form. What is third form? Third form is when the answer is given still in a square root form. Okay, to make a calculation more accurate. Next, here we are given that the distance of the ball above the ground is 5.5. So we just put it into the equation so that we can find the t. Okay, I transform the value of t into a fraction, which is 11 over 2, and then value of 5 equal to 10 over 2 plus 40 negative t square. Okay, I eliminate all the element on the right hand side to the left hand side so that can make it into a specific form that we can put into a quadratic form. Here we can see that the quadratic form. Okay, in quadratic form, we can substitute the value of a, which is 1, t square is 1, and then the value of b is equal to negative 4, and then the value of c is 1 over 2. Here, the only difference between t1 and t2 is the negative and positive signs. Because we have two methods, two ways, which is the positive and negative, we have two answers. Okay, T1 and T2. After all calculation, we get the answer for T1 and T2. Next. Here we can see that at the value of T1, which the ball reached the height of 5.5 meters, is 0.129, and then the T2 is 3.871. Okay. Is there any question?
Excuse me, but how do we know that it is T1 and T2 for 0.120,
Oh.
5.5, and 3.871, 5.5?
Okay, we get the answer for T1 and T2 by just insert it into your calculator. Just type on that value. Then we get the T2 value 3.871, and then the T1 value is 0.129. Okay, why do we have to subtract both? Okay, so that we get the time difference taken for the ball when it reached 5.5 meter. Remember, when this ball go up 5.5, we calculate the time, and then when the ball goes down, we calculate the time, and then we subtract both. Next. As I said, we have to subtract both. Remember, the upfront one must have the larger number than the behind. Okay, just like now, T2 have the larger number and then T1 has smaller one, and then we subtract both. Here we can see that the denominator is the same, 2. Okay, I just subtract it. Remember the bracket and negative outside. Okay, subtract 4, eliminate 4 because it has the same value, eliminate, and then we left with a square root 14 plus square root 14 over 2. And then we cancel out the 2 because the denominator is 2. Okay, we cancel out 2, we left with square root 14. Okay, time difference taken for the ball which reach height 5.5 meter above the ground is square root of 14 seconds. Thank you. And that's all from us. Thank you for watching. See you later.
Boleh, boleh.